Hi, this is Adhay Rabi and you're watching AirTube. Today we'll talk about oxidation reduction and oxidation number. Several definitions of oxidation reduction evolved during the journey of chemistry. The first one is based on oxygen transfer. If oxygen is gained, we call it oxidation. When magnesium reacts with oxygen, it gains the oxygen and produces magnesium oxide. We say magnesium is oxidized. Losing oxygen means reduction. For example, copper oxide, when lose oxygen to produce copper, we say copper oxide is reduced. Another definition is based on hydrogen transfer. When hydrogen is lost, we call it oxidation. Like here, hydrogen sulfide lost hydrogen to chlorine and becomes sulfur. Gaining hydrogen is called reduction. In this reaction, chlorine gained hydrogen and formed hydrogen chloride. So chlorine is reduced. The recent definition is based on electron transfer. Loss of electron means oxidation. Like a reaction between magnesium and chlorine. One part of the reaction is when magnesium lost 2 electrons. So this is oxidation. Again, getting electron means reduction. Like iron 3 chloride when react with hydrogen sulfide becomes iron 2 chloride. Here, iron 3 is gaining 1 electron to become iron 2 and that's reduction. I know these definitions are not enough to understand oxidation reduction completely. But trust me, when we finish this journey, we will master this topic. Oxidation and reduction always takes place together. Let's observe the reaction between copper oxide and hydrogen where hydrogen gained oxygen and become water. So hydrogen has been oxidized. On the other hand, copper oxide lost oxygen and becomes copper, therefore reduced. These two events happening at the same moment. That's why we call them redox reactions. In another example, zinc is converting into zinc ion by losing 2 electrons. At the same time, a copper ion is gaining those 2 electrons to become copper metal. Losing electron means oxidation and gaining electron means reduction. So oxidation reduction takes place all together. Electron transfer theory is considered the most acceptable theory. Question is why? Consider this reaction where no hydrogen is present. So we can't explain redox using hydrogen. Now consider the second reaction which can't be explained by oxygen transfer because no oxygen is involved. The third example is even more interesting. Here we won't find oxygen or hydrogen. But all these reactions can be easily explained using electron transfer theory. For example, the formation of sodium chloride. This reaction has nothing to do with oxygen or hydrogen, but we can see sodium lost electron, that's oxidation, and chlorine gained electron, that's reduction. So electron transfer theory can explain all redox reactions. Now we need to understand redox and oxidation state. So what does oxidation state mean? Oxidation state tells us how many electrons each atom of an element has gained, lost or shared in forming a compound. Or you can say that the oxidation state is the charge an atom of an element would have if it existed as ion in a compound. Oxidation state is also known as oxidation number. We can identify oxidation reduction from their change in oxidation state. Look at this flowchart carefully. A rise in oxidation number means oxidation has occurred. For example, from -2 to 0 or from 0 to +1 or +1 to +4. A fall in oxidation number means reduction has occurred. For example, from +4 to +1 or from +1 to -3. There are some rules about oxidation state. The oxidation state of a free element is 0, whether the element is monoatomic copper or diatomic oxygen. When it is element, the oxidation state is 0. The oxidation state of a simple ion is same as the charge of the ion. Like oxidation state of potassium ion is +1, zinc ion is +2, chloride ion is -1, and oxide ion is -2. The oxidation state of all atoms present in the compound add up to 0. For example, in magnesium oxide, the oxidation state of magnesium and oxygen may be different, but for compound, it is 0. Look at the compound magnesium chloride, where 2 chlorine is present. Magnesium has oxidation number +2 and chlorine has oxidation number -1, but their sum is 0. For a polyatomic ion, however, the oxidation number is equal to the charge of the ion. Sulfate, for instance, will have total oxidation number -2. In the ion, sulfur has +6 and 4 oxygen present has oxidation number -2 into 4 -8. The sum of +6 and -8 gives us total -2. Now remember this table for future. These elements have only one oxidation state. Group 1 metals including hydrogen has oxidation state +1. Group 2 has +2 and group 7 or halogens has -1. Apart from them, aluminium has +3 and oxygen has -2. Remember, in hydrogen peroxide, oxygen has oxidation state -1. That's the only exception for oxygen. Atoms of transition elements can have variable oxidation states in their compounds. Look at this table for elements iron, copper, manganese or chromium. For non-metals like carbon, nitrogen, sulfur or phosphorus, they also have multiple oxidation number. Elements with multiple oxidation states are complicated to remember, but we can easily calculate them using data from our previous table. Now let us apply our knowledge to identify oxidation number of a transition element. We have potassium dichromate and we want to calculate the oxidation number of chromium. We know potassium is from group 1, so its oxidation state is +1. And usual oxidation state of oxygen is -2. 2 potassium is present, so total oxidation number is +2. 7 oxygen is present, so total oxidation number is -14. As for chromium, we need to calculate it. We know the sum of the oxidation numbers of a compound would be 0. So using this law, we can establish a mathematical equation. By solving the equation, we get the oxidation state of chromium, which is +6. Now we want to identify oxidation number of an element from a polyatomic ion. So we have manganate ion. We want to calculate the oxidation number of manganese here. We know the usual oxidation state of oxygen is -2. 4 oxygen is present, means total oxidation number is -8. As for manganese, we need to calculate it from the sum. We know the sum of the oxidation numbers of an ion would be equal to charge. So manganese plus 4 oxygen would be -1. After solving the equation, we get the oxidation state of manganese in manganate ion is +7. See, that's easy. We now understand oxidation number, redox process and their relation with oxidation state. In this part, we want to find out redox reaction and change in oxidation state. This reaction is between sodium and chlorine to produce sodium chloride. We know free elements have oxidation state 0. So sodium and chlorine given 0. But in the compound, their oxidation state is +1 and -1. We can conclude some points from here. Oxidation number of elements changed, so this is a redox reaction. Oxidation number of sodium increased, so sodium is oxidized. And oxidation number of chlorine decreased, so chlorine is reduced. See another reaction of copper with silver nitrate. Even from an ionic equation, simply by deducing the change in oxidation state, we can identify a redox reaction and where the oxidation or reduction actually happened. Oxidizing and reducing agent. At this topic, learners usually get confused, but not to worry. We will cover definitions and examples to clear our concept. A substance that causes another substance to be oxidized is called oxidizing agent. An oxidizing agent is reduced in the process. Some common examples are sulfuric acid, nitric acid, potassium permanganate, potassium dichromate, and hydrogen peroxide. A substance that causes another substance to be reduced is called reducing agent. The reducing agent is oxidized in the process. Some common examples are carbon monoxide, hydrogen sulfide, potassium iodide, hydrogen gas, sulfur dioxide gas, and ammonia. So the summary is that substances that go through oxidation is called reducing agent because by oxidizing they help others to reduce. Similarly, substances that go through reduction is called oxidizing agent because they help others to oxidize. To make it more clear, let's assume A is a substance donating an electron to B. So A lost electron and oxidized, whereas B gained electron and reduced. A is oxidized, so it must be reducing agent. On the other hand, B is reduced, so it must be oxidizing agent. How can we identify oxidizing and reducing agent? The answer is simple, by detecting oxidation and reduction. And how do we do that? By calculating their oxidation state. We know if oxidation number is increased for an element, it is oxidized, and if oxidation number is decreased, it is reduced. Take the reaction of hydrogen sulfide with chlorine. If we calculate oxidation state of all elements here, we'll see that chlorine changed its oxidation state from 0 to -1. So oxidation number decreased, means chlorine has been reduced. So it will be oxidizing agent. Similarly, sulfur changed its oxidation state from -2 to 0. So oxidation number decreased or sulfur has been oxidized. So it will be reducing agent. We will now accumulate all our information to a single place. Let's observe an ionic compound formation by magnesium and chlorine. What happened during the reaction is 2 electrons from the outer shell of magnesium go to the outer shell of 2 different chlorine atoms. So magnesium lost 2 electrons or oxidation happened to magnesium. Therefore, magnesium is reducing agent. Both chlorine atoms gained 1 electron and reduced. Therefore, chlorine is oxidizing agent. If we talk about change in oxidation state, since this is an ionic compound, so before reaction they were element and their oxidation number was 0. But after forming compound, charge of magnesium is +2 and charge of both chlorine are -1. Charge of magnesium increased from 0 to +2, which implies oxidation of magnesium or magnesium is a reducing agent. On the other hand, Charge of chlorine decreased from 0 to -1. So reduction happened to chlorine. As a result, we can say chlorine is an oxidizing agent. Okay, that's all for today. Hope this video will clear your concept about oxidation and reduction. If you have any question regarding this topic, leave me a comment and I will try to answer. See you later. Take care.